Well, welcome to Graphical Transformations. This is section 6 of chapter 1. And our learning targets for this lesson are to be able to write equations of any of our 12 basic functions after we apply different transformations, and to be able to graph those transformed parent functions without using a calculator. Okay, so you're really going to need to know how to use, or you're really going to need to be familiar with your 12 basic functions. So make sure that you have those memorized, what the graphs look like and what the equations are and things like that, and what those the critical points were. So first of all, I have this table for you that describes the various transformations. And in the first block, these are all translations. Now, translations are also called a slide, and those can be left or right. We'll talk about that in a minute. And then the middle block here are stretches and shrinks, also called dilations. And then the bottom box here is a reflection. So let's start with the top box here. We have f of x plus c. When you have a number added inside the function, that represents a horizontal translation, and it goes left c units. So you end up subtracting c from the x coordinate in your original point. And then if you have f of x minus c, that's translated to the right c units. And then if it's on the outside of the function, so if you have the function and then a number is added outside of that function, that would be a vertical translation. So that one would go up d units. And if it's subtracted from the function, it goes down d units. So that only affects the y coordinate when you're going up and down. If you're translating left and right, it only affects the x coordinate. Now down here for stretches and shrinks, these get a little bit confusing with remembering what the scale factor is. So when you have your function multiplied by a number inside, so all of this left side is inside of the function, that represents a horizontal shrink, and the factor is the reciprocal of whatever it's multiplied by. Okay, so if you have 2x, that would be a horizontal shrink of 1/2. So you're going to take all of your x coordinates and multiply by 1/2. Now, if you have a fraction, if you have, say, x over 2, that would be a horizontal stretch by a factor of the reciprocal, which in that case would be 2. So you multiply all of your x coordinates by that number. If you have your function multiplied by a number outside of the function, then that would be a vertical stretch by a factor of a, only affects the y-coordinate, so you multiply the y-coordinate by whatever the function is multiplied by. If the function is multiplied by the reciprocal of a number, that's a vertical shrink by the factor of 1 over a, and it only affects the y-coordinate. So the only ones that are weird are these horizontal shrink and stretches. They're the opposite of what the factor says. So if it's inside the function, the factor is the reciprocal of the function when you're doing a stretch and a shrink. For reflections, when we have a negative x and we put that into the function, that is a reflection over the y-axis, only affects the x-coordinate, and the x-coordinate gets negated, or you take the opposite of it. If you have a negative outside of the function, that's a reflection over the x-axis, and that only affects the y-coordinate again. So you'll notice all the y-coordinates over here on the right-hand side are on the outside of the function. All the x-coordinates are affected when it's on the inside of the function. So I hope that makes some sense for you. So one of the things I wanted to make sure to mention to you is to make sure that you do any stretches, shrinks, or reflections before you do any translations or slides. So let's go ahead and jump into some examples. Example 1 says, describe how the parent function can be transformed to the graph of the given equation. So the parent function for letter A is just y equals the absolute value of x. So this one is outside of the function. So this is going to be a translation, and it's negative, so it'll be down 4 units. So it's outside the function that tells us it's down 4 units. This one is inside the function. It's inside the parent function of the absolute value of x. So this one's going to be a horizontal translation, so it's only going to affect the x coordinate. and that will be to the left 2 units. On letter C, we have two things going on here. We have a -3 outside the function and a +2 inside the function. So we've actually got two different things going on. The -3 outside tells us it's going to go down 3, and the +2 inside tells us it's going to go left 2. So inside the function's left 2 units, down 3 for outside the function. Example 2 says find the equation for the reflection of the function across each axis. So I put as a reminder, I put each of these equations in here. If we're reflecting across the x-axis, it's outside the function. And if we're reflecting across the y-axis, it's inside the function. So let's start with letter A. And what we're going to do is we're just going to stick a negative outside of f of x. So rewrite f of x and then put a negative in front of it. And then distribute your negative through the parentheses. We get -5x plus 9 all over x squared plus 3. You could also choose to write that as 9 minus 5x in your numerator. Either way is fine. Letter B, across the y-axis, everywhere we see the letter x, we're going to replace that with a -x, so I've done that here. And then get rid of your parentheses. So 5 times -x is -5x, and in the denominator, when we square a -x, we still get a positive x squared. So they're very similar, we just have one sign that's different. Example 3 says perform the following transformation on the graph. So we have this given graph in black. Letter A says take the function, and we have inside the function a -3, so that's a horizontal translation because it's inside the function, and that will be to the right 3, and then outside the function it says +2, so it's going to go up 2. So we're going to go right 3 and up 2. So what that ends up looking like, if I just take every point here and go right 3, 1, 2, 3, and then up 2, 1, 2, and so this top point becomes that point. And we can do that for every single point on here, and then we can go ahead and connect the dots, and that would be our transformed function. So one more here, right 3, 1, 2, 3, up 2, and that should be what our function looks like. And I'm not going to take the time to go ahead and connect the dots, you can get the idea. So letter B says if we have a negative outside the function, and then we have a 1/2 inside the function. So this is going to be a horizontal stretch by a factor of 2. That's the 1/2 part. And then it's going to be a reflection about the x-axis because it's outside the function. So what you would do for this one is you would go ahead and pick some values. So these are the original values for these 4 points. And what you're going to do is you're going to go ahead and multiply each of the x variables by 2. That will be the horizontal stretch. And then you're going to do the reflection about the x-axis. And what that's going to do is negate y. Okay, so here's 2 times all of the x variables, and then the opposite sign for the y variables, and then just replot those points. So that one I'll just go ahead and do that one in blue. So we have the point -4, -4. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4. Should be down here somewhere. 0, -3. Whoops. X is 0, y is -3. It'll be right here. 2, 0 will be on our x-axis right here. And then 8, 1 should be right there, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 1. So you can see what that would look like. And then lastly, we have letter C. And this one, they're both inside the function. So we have a horizontal translation. This one's going to be to the left 3 units. And then the 2 is also inside the function. So that will be a horizontal shrink by a factor of 1/2. Horizontal shrink by a factor of 1/2 and left 3. So remember I told you we needed to make sure we do our shrinks first, and then we're going to do our translation. So here are our original points. So we're going to do the shrink first. So we're going to take half of all of the x variable. And so that's in the column here, the second column. I took 1/2 of x. And then from that number I subtracted 3 for the for the left 3. So here are our new x variables right here, our new x coordinate. The y coordinates didn't change. So we can go ahead and graph those. And we get -4, 4. So let's see if I can do this over here, -4, +4. So we're going to go left 4, 1, 2, 3, 4, 1, 2, 3, 4. That'll be up here. And then we're going to have -3, 3. -3, 3 is right there. And -2.5, 0 is about right there. And -1, -1. -1, -1 would be about right there. So you can see it's a shrink, and it's also a, moved left three places. Our last examples here say graph the functions by transforming their parent functions. Well, the first one, letter A, we have the square root function. So the parent function is y equals the square root of x. So what we would have to do first here is we would have to go ahead and factor inside the radical. So we could factor out a 3 from both terms. So we get 3 times x minus 2 in parentheses. And the x minus 2 tells us that we have a translation 2 places to the right. And the 3 tells us that we have a horizontal shrink by a factor of a third. That's covered up right now. I have to go ahead and show you that real quick. So that's what's going on in this one. So let's go ahead and get our table of values. So our parent function is this. And in the parent function, where it's just y equals square root x, put in a couple of values. Now I put in 9 just because I know that's going to work out nicely in my transformed function. So the next thing we need to do is to do our shrink first, right? So we're going to multiply all of our x variables or our x coordinates by a third, and then we're going to add 2 to that. So here we go. Our original x variable, 1/3 of that, and then 1/3 of that plus 2. So these are the x coordinates that we want to graph. The y coordinates don't change. So we need to plot the point 2, 0. X is 2, y is 0. X is 7/3, y is 1. And so 7/3 is actually 2 1/3. So we're going to go 2 1/3, just a little bit further than this, and up 1. So maybe about right there. And then the point 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. That would be right there. So our function would look something like, let's see if I can get a good picture here for you. So remember the square root function. Whoa, hard to draw with this, but if you imagine a curve there, that's what that should look like. Let's move back over to the function over on the right-hand side. And that one's a logarithm. So I wanted to go ahead and remind you of some properties of logarithms. So this says the log base 3 of this, this expression. And its parent function would just be the log base 3 of x. Okay? And we can write that either in log form or in exponential form. And I just set it equal to y. Y is the same as f of x. So the other thing we could do in exponential form, the conversion from logarithmic to exponential form is, I provided that for you here so you could see what that looks like. In case you've forgotten what those two different forms look like, it says take the base to the right hand side y, to that y power is equal to x. So let's go ahead and transform this function, or see what transformation has taken place. So we could rewrite that as the log base 3. If I just put the x term first, it's minus x plus 5. But then what I'm going to do is I'm going to introduce a parenthesis there. And when I do that, it makes it x minus 5. So you can actually see what's happening here. The x minus 5, this is inside the function, and that's a horizontal translation to the right 5 units. But then the negative, also inside the function, tells us that we also are going to be reflecting that across the y-axis. So the transformation is right to the move right 5 and reflect across the y-axis. So here we go. We need our table of values to begin with. So I have our 3 values that work in the original function, where we have y, or log base 3 of x. So those 3 values work in our log function. If you don't understand where to get these, please ask me in class and I can explain that and do a little review of logarithms with you. So the next thing we need to do is we're going to do our move right 5 units. So we're going to add 5 units to our x coordinate after we reflect it across the y-axis. And remember, the y is going to stay the same, but we have to take the negative of x. So the negative of our x coordinates is here, and then add 5 to that gives us the red values. and then we need to plot those points. So we would have the point 4, 0, which will be right here, and the point 2, 1, which will be right there, and then the point negative 4, 2, negative 4, positive 2. So that's what our function will look like. So normally our logarithm, if you remember, it kind of looks like the square root function in a way, and this one has been reflected across the y-axis, so it's going the opposite direction. That's it for this video. We'll see you in class.